writing a set of plans for a project can take upwards of 100 hours. And I really don't enjoy it. Nobody else can do it for me. Really, the plans have to be written by the guy who designed the project. So I'm trying something new here. It's much easier to make a very detailed video about a project than to write a detailed set of plans about it. So for the project that you're about to see, I've made 2 videos. The one that you're watching now is a shorter video intended for entertainment and education purposes. But if you want to actually replicate the project, I'll be uploading a longer, more detailed video that gives you all of the dimensions you need to actually build this thing. I'll be uploading the longer video hopefully around December 10th. So watch both videos if you can, and let me know what you think. Especially from those of you who actually built this project based on the video, I'd like to hear how it went. This is just an experiment, and I want to know your honest opinion. If you hate this, please tell me that. Okay, enjoy the video. Back in April, I built this heavy-duty 2x72 belt grinder, and since then it's been sitting on my dad's workbench on top of this stack of 2x8s. The sad thing is, this machine was intentionally overbuilt, and yet because of what it's sitting on, I can do this. I think it's time I build a dedicated stand for it. The signature feature of this grinder is that it can serve as either a vertical or a horizontal grinder, but because of that, the motor, which is direct drive on the drive wheel, has to swing down, as you can see here. So it needs some extra height in here. About 3 options to deal with this. One is to just set it on top of blocks like this. You could make the legs on the grinder longer so that you can mount directly. Or the solution that I'm going with is to custom build a table that's notched out so that the motor has a place to swing. Just to give you a quick look at the construction before we get started, it's going to be a front and back frame, nearly identical, just that one of them is notched for the motor. They're connected by a bunch of cross members. On this corner where the notch is, that'll be skinned to keep dust out, and the back will also be skinned to add rigidity and keep dust out. The top will have a piece of 1/4-inch plate bolted down, and then in the front there will be 2 banks of wooden drawers. So I'll start by building the front and back frames, which are completely flat, so I can just put them together on this table. So I just copied and pasted 2 more of these, and then this one is shorter. That's the one that goes on the corner with the motor notch, which is 7.5 inches deep. I'm going to go ahead and weld up this front frame right now. So now all that's left to do is put in the middle tube right here. It's important that this piece be exactly centered side to side. Okay, that's the front frame all done. You can see here where the 2 banks of drawers will go. And now let's move on to making the back frame. This is that jog piece that goes in the middle to create the notch. If I put it on top of this one, it makes this leg the same height as all the others. So it's sort of like I've just cut this piece off and scooted it over to here. Now I just need to make the piece to fill this in and this. Need to put in the 1.5-inch tube across the bottom and up the middle. Now we're ready to connect those, so I just need to cut a bunch of cross members. I I'm just putting a few tack welds here and there and then checking everything for square again. The more square this is, the better, because if it's out of square at all, the drawers probably won't work as well. These two small tubes are to hold the panels that will support the drawers. I'm working on the jogged crossmember now. This crossmember goes on the right-hand side of the cabinet and is the second piece to the puzzle that creates the notch. The front foot of the grinder is going to sit right here, and then the back foot sits about here, so there needs to be a cross member between here and this tube. There is one more piece I'm going to add here that's mostly just for looks. So I'm welding these 3-inch square feet on the bottom. If you wanted, you could certainly put leveling feet on this or casters. So all the feet are attached. Now all we need to do is put the skins on the back and in this notch. I welded these plates on solid all the way around. It didn't take as long as I thought it would. So here's the piece I cut to fit in the bottom of the notch. You can see the corners are both cut out a little bit. And those are to fit around the weld. I think I'm just going to try to bend a single plate around this. I need to bend it here and here, so I'm going to score that with the grinder. That'll give me a spot for it to bend. It is possible that the plate would crack along these cuts, but I don't think it will. I'm willing to take the risk. And with a coat of paint, the frame is all done. Now we can move on to making the drawers, which will be based on my modular drawer system that I've used in the past. As a refresher on how my modular drawer system works, the drawers are all built on an 1.5 inch increment. And in here, we have a dado cut every 1.5 inches. So as long as all the drawers are built on that same increment, any drawer will fit anywhere. My tool stand is going to be built the same way, so I need to cut plywood panels for the sides that have a dado every 1.5 inches. I cut my 4 panels, and now they need to be notched out in the corners to fit around the horizontal tubes. So now we just need to cut those grooves in here, and then we'll screw it in all the way around the perimeter. Here I'm using the jigsaw to notch out the corner of the panel that goes where the motor notch is. This had to be done for both of the panels for that right bank of drawers. Nice. I got all 4 panels installed and fitting correctly, so now it's time to screw those in place, which I'm going to do with these little 1032 by 1 inch countersink head screws. Okay, all 4 panels are screwed in place. Now on to making the drawers. Every drawer needs to be able to fit in the narrowest spot on here without binding, since they're interchangeable. The way to determine where that narrowest spot is, or rather how wide it is to just cut a panel and try it in every spot. and that one's tight. So I'll just have to trim that down to where it fits nicely, and then I can cut all the other bottoms to the same size so they'll all fit the same way. This was the spot where it fit the tightest before, so sweet. These are the 15 drawer bottoms. They're 24 inches long, except for these 3 which go where the motor notch is. So now we just need to cut the sides, backs, and the fronts. That's all the drawer sides for all of the full-length drawers. So these are all of the sides and the backs for all of the drawers. Here's what we have so far. Now I just need to make the front, which is made out of 3/4 inch plywood. And if you're starting to get bored of all this cutting, keep in mind this is edited. It took hours in real life. And there's the OCD kicking in again. Since the bottom is inset into the front, we need to cut a rabbet along the bottom of the front. There's one more thing we need to do. We need to notch out these corners so that the sides can inset into them. It fits like that. That's how it's supposed to work. I went ahead and cut the rabbets along the bottom and the notches in the ends of all of the fronts. And now I'm using an 1/8 inch roundover bit to ease the edges. Alright, all of the components of the drawers are done and ready to glue up. The glue up is quite straightforward and usually only takes about 10 minutes. First the sides are glued into those little notches in the front. Then the back is glued between the sides. Then the false back is glued in using a spacer to keep it at the right distance from the back. I go into detail on what the false back is for in the other video. And finally, the bottom can be glued on. Cute little drawer. I got all the drawers done. They run kind of hard right now, and we can improve that. Just putting a little bit of wax on those slides. It is kind of incredible how much difference this makes. Time for some handles. I came up with this design. The handles nest together very well, so you can get a lot of them out of a small amount of wood. This part you get your fingers under is thin enough that this thing doesn't have to stick out very far from the drawer, and yet you have plenty of room underneath here for your fingers. That's easily strong enough. And the ends here are thick enough, you should be able to drive a screw into that without it splitting, although you definitely do want to pre-drill it. Almost done. All I need to do to finish this up is make a piece for the top and mount the grinder and the frequency drive. I painted the bottom side of the steel just to prevent it from rust, but the top side doesn't need to be painted because it'll get beat up. I went with a piece of 1/4 inch steel plate for the top. It only cost about $40. If you went with plywood, you'd probably need to replace it every couple years, and once you replace it 2 or 3 times, it's going to cost you as much as the steel did. So I'm going to go ahead and screw this down. So I got the holes for mounting the grinder drilled, and the 2 holes here for mounting the pedestal that will hold the frequency drive. And now I need to take the top off and drill all of the holes out. These little ones will be drilled out big enough for those screws. And then these will be drilled out to probably about 1/2 inch. And all of the small holes will be countersunk to house the head of that screw. I tapped the holes that will hold the grinder and the VFD pedestal to 3/8/16, and then all of the other holes to 10/32. And the top is held down by the same screws that hold the plywood panels into the sides. And now, finally, we're ready to mount the grinder. Until now, the frequency drive was always just sitting here beside the grinder, so I need to mount it somehow. I was thinking a pedestal that would hold it up here would be just about perfect. I have a design for the pedestal, but I don't know yet how high I want it, so I'll have to determine that. That feels a little high to me. That's more like it. We need to mount this down to the table with these 2 3/8 bolts. So I need to cut just a little plate that I can weld onto the end of this. So I've cut these triangles. I'll tack weld all of that together before I weld it solid, and then everything should stay square. Up here at the top, I want to put a cover on that just to keep the bees out of there. So now I'm ready to mount the frequency drive here. I'm going to go ahead and mount the post, and then we'll tap those holes and mount the VFD. The bottom holes on here are actually slots, so I can just set it on there and then use a screw in the top to hold it in place. It's done! Honestly, when I started this project, I wasn't very excited about it because it was just kind of one of those things that had to be done. There was nothing acceptable about having this grinder on top of some 2x8s. But it's turned out to be one of my favorite projects yet. The 1/4-inch thick steel top is going to be a lot more useful work surface than I had thought it would be. In fact, I kind of want a whole workbench like this. This position for the frequency drive is way better than having it beside the grinder. The height of the grinder is much better than it was. Before it was about 4 inches higher, so the table was right here. This is way more comfortable. And have I mentioned how nice it is to finally have the grinder nice and rigid? Overall, I'm just super pleased with how this turned out, and I'm going to get a ton of very good use out of this. Thanks for watching.